Hello students. In the last class, students, just we have to discuss about the basic types of functions and how the testing process is to be done for the each and every kind of functions. We have to see this thing in the last lecture. Is it to be clear? Today student, we are just discussing the related exercise 1.2 related to the functions. Is it to be clear? Where basically we have to see the various type of questions, and where basically in each and every question student you can see that the testing process is to be done. Is it to be clear? Means how the particular question is to be there and how we will solve each and every case we have to discuss here, and how to write the case of 1 and on to each and everything we will declare in the very deep. Is it to be clear? So today we are started the exercise NCERT exercise 1.2, and each and every question student we have to see carefully here. Then after definitely you will get the concept automatically here. Is it to be clear? So we will start the very first question of your NCERT exercise. So basically the very first question is to be given here. In this very first question, so that the function f r star means basically this is not the set of real numbers, something is to be the missing from r star. So r star is to be defined at the last of this function, and any function is to be written as fx equals to 1 upon x is 1 and on 2, where r star is the set of all non-zero real numbers. A very important thing student, non-zero real numbers means we can say that these are the set of real numbers which does not include the 0. Is it to be clear? If the domain r star is to be replaced by n with the codomain being same as r star, is it to be clear? Then what should be the result? So there are two type of questions is to be asked here. So again we have to see the answer of this question. Suppose student here in this case, in the question number very first question, we are saying that basically any function f of x is to be given as 1 upon x, and this is to be given from r star to r star. What is the r star here? So r star is to be defined as the set of all non-zero real numbers, set of all non-zero real numbers. Is it to be clear? So basically student, in the r star just we are taking the set of all non-zero real numbers. Is it to be clear? Now we have to check whether the given function is 1 or not. So basically student, first of all we can say that 1. We have to take the first case, that should be the 1. Then let x1 comma x2, let x1 comma x2 belongs to the r star. So basically we have to take the two different elements from the r star. R star means set of all non-zero real numbers. So basically we have to take the two numbers such that f of x1 equals to f of x2. Is it to be clear? Now student, we can say that this is 1 upon x1 and this is said to be the 1 upon x2 as per the definition. Now you can do the cross multiplication. Definitely student, you can say that x1 should be equals to x2, because here r star is to be given as the set of all non-zero real numbers, means we cannot take any of 0 here. So definitely if we have to do the cross multiplication, then definitely we have obtained, because here you can say that x1 comma x2 both belongs to the r star, means x1 equals to x2, the condition is to be obtained here after just solving this part. Then you can say that this is the case of 1. So you can say that, so it is 1. So it is 1 or injective mapping, you can say that. So it is said to be the 1 function. Is it to be clear? So the very simple part is to be there to check the 1 case. Now the second case student, just we are saying that onto. What should be the case of onto here, and how we will check the onto function? So in the last class just we have to discuss the very important definition related to the onto, where we are saying that if codomain element, each and every codomain element of the function has the pre-image in domain or not. Suppose any of the element does not has the pre-image, then it is not said to be the onto, means that function should be automatically become the into part. But here student, we have to see this thing in such a way that let f of x equals to y, f of x equals to y, f of x equals to given as 1 upon x equals to y. So after simplifying this part, you will get the y equals to, you can say that just we can say that here just we will write down the value of x, that should be the 1 upon y. So after taking x equals to 1 upon y, student, this particular y belongs to the R star. R star means any non-zero real numbers are to be there, means you cannot take 0. In spite of 0, you can take any value of any real number. Is it to be clear? As the value of y. So you can say that for all y belongs to R star, definitely implies x belongs to the R star. Means suppose any of the real number you can use except of 0, because 0 is not to be included in the R star. So definitely you can take either 1, 2, 3, 4, then it will become 1 upon 2, 1 upon 3, 1 upon 4 like this. Then definitely x will be also belongs to the R star, means x can be the any of the real number, means you can say that the codomain element has the pre-image in domain. So it is said to be, so it is onto. So it is onto function. Is it to be clear? So basically student, in this particular question, just we are describing what in the case of onto, just we are saying and just we are thinking that process, whether the particular codomain element has pre-image or not. And another definition student we have to also tell in the last class, if any of the codomain should be equals to the range part of that function, then it should be automatically set to be the onto. So either of the work you can do here, no problem. So in this very first question student, the question is to be given like this, and just we have to prove that whether the function is 1 1 or not, or onto or not. So easily you can do the simplification of the answer question. Is it to be clear? Next one is the student, if this particular R star, means the domain R star is to be replaced by the natural number. Any other question is to be also asked in this particular part. If suppose any of the R star is to be get replaced by the natural number, then what should be the result, and what should be the answer of this particular question. So pause the video to note down this answer, then after we will simplify the next part of this question. So in the next part, another function is to be defined from natural number to R star. Now this R star is to be get replaced with the natural number, and again the definition f of x would be given as 1 upon x. Now we have to check again both the cases, either function is said to be the 1 1 or not, onto or not. Is it to be clear? So again we are use the same process. So we can say that let x1 comma x2 both belongs to the natural number. And student, I think each and every student know very well about the natural number, because natural number will be started with the 1. So 1 2 3 4 5 like this. Is it to be clear? And such that f of x1 equals to f of x2. Is it to be clear? Now you can use the definition of function 1 upon x1 equals to 1 upon x2. After doing the cross multiplication, you will get the required result as x1 equals to x2, because x1 and x2 both belongs to the natural number. Is it to be clear? So basically it is said to be 1 1. So it is 1 1 or injective function, you can say that. Now the second part is corresponding to the onto or surjective or not. Is it to be clear? So now again we are use the same process as we have done in the last question. So let f of x will be taken as y, then it should be written as 1 upon x, and here student x will be written as 1 upon y. Is it to be clear? So we will get the value of x equals to 1 upon y. Now what is y? Y belongs to the codomain, and codomain of this function will be R star, and R star is said to be the set of all non-zero real numbers. So basically you can say that for all y belongs to R star, suppose we are taking any of number, suppose y equals to taken as 2, then this x will become 1 by 2 here. Suppose y equals to 2, suppose if y equals to 2, then 1 upon y equals to 1 upon 2, and 1 upon 2 does not belongs to the natural number, because student any of the codomain element has the pre-image in the domain always. But here suppose we are taking 2, then it will become 1 upon 2, and 1 upon 2 the value of x, and x will belongs to the natural number, but no any kind of natural number has the fractional number. That's why we can say that for all y belongs to R star, x does not belongs to the natural number, and so it is not onto. So it is not onto function. Is it to be clear? So basically student, this particular function is not said to be the onto, then automatically this particular function will become the into function. Is it to be clear? So definitely student, if we have to replace the R star by the natural number, then what should be the result? The result will be the function will be 1 1 but not set to be the onto, and the function will automatically become the into. Is it to be clear? Now this is the answer and solution of the very first question, student, of your NCERT exercise 1.2. Now we will take the second question. Is it to be clear? And we will use the same process for solving each and every question. So you have to see carefully each and every part so that the concept will be automatically get clear to each and every student. So next part we are taking here. Next part of the exercise 1.2, question number 2 we are taking. So the question number 2 is, check the injectivity and surjectivity of the following functions. Some of the functions are to be given. Is it to be clear? Here you can see the student, fx equals to x square, fx equals to x square. Again means in each and every case it is to be written as fx equal to x square, x square, x square. But in these two parts it is written as x cube. But here you can check this particular part. This particular domain and codomain will declare the function as 1 1 or not. Means the checking and testing process will be dependent on the domain or codomain. Is it to be clear? So here the domain is to be given as n to n, natural number to natural number. Here z to z, here r to r. Again n to n or z to z. So each and every case we have to discuss. Is it to be clear? And carefully student, if we have to see each and everything, then definitely the concept of 1 1 will be automatically get clear to each and every student. So we will take the very first part of question number 2. So in the question number 2 of your NCERT exercise, the first part is to be given as any function f is to be given from natural number to natural number, and it is written as fx equals to x square. Now we have to check the injectivity or surjectivity, means we have to just check the 1 1 case and onto case here. Is it to be clear? So basically very first part we have to check for the 1 1. So in the case of 1 1, let x1 comma x2 belongs to the natural number, and in such a way that, or you can say that, such that f of x1 should be equals to f of x2, and here you can write x1 square equals to x2 square. Is it to be clear? Now student, if x1 square equals to x2 square, then definitely in general we are saying that the x1 equals to plus or minus x2, but in this case what is x1 and x2 here? So definitely x1 and x2 both belongs to the natural number. So definitely student, if both belongs to the natural number, then any of the natural number cannot be negative. So basically here you will get the result x1 equals to x2 only, not plus or minus x2, because here x1 comma x2 both belongs to the natural number only. That's why only we will get the result x1 equals to x2, not plus or minus, because no any natural number cannot be negative. Is it to be clear? So it is said to be 1 1. So you can say that, so it is 1 1. Is it to be clear? Next we will check for the onto or surjectivity of this function. So for the surjective case, student, let f of x equals to y. Let f of x equals to y. Then we can say that x square is said to be the y. X square equals to y. Then definitely student, you will get the value of x as plus or minus root y. But here only we have to take the plus of root y, because here x belongs to the natural number. We have to keep in mind this thing. Always any natural number cannot be negative, so only we have to take the plus sign only. Is it to be clear? No negative sign is to be taken. Now student, just we have to convert the process. Now we will check for the pre-image of codomain element. So what is the codomain here? So you can check in the function that given codomain is again said to be the natural number, means just the value of y we have to take the natural number. Then we have to check the pre-image of any codomain element in the domain, whether it is existed or not. So basically for all y belongs to natural number. Suppose we are taking any of the natural number. Suppose let we have to take the y equals to 2, then x will be equals to root 2, and root 2 does not belongs to the natural number. There are so many examples you can take here. Is it to be clear? No, this particular y is to be taken as 2. You can take 3 also, you can take 5 also, you can take 7 also, because no particular square root number is to be there, and no perfect square root number is to be belongs to the always natural number. So you can say that for all y belongs to natural number, x does not belongs to the natural number. X does not belongs to the natural number, so it is not onto. So it is not onto means this particular function is always said to be the into. Is it to be clear? So in this part student, you can just provide this example for the understanding purpose. Then automatically the examiner will understood that whether it is to be correct or incorrect. So definitely we have to mention the such type of examples. Then definitely you can say that this particular element 2 will lie in the codomain, but this 2 does not has the pre-image in the domain. That's why the function is not said to be the onto, and not onto means this function is said to be the into function. Is it to be clear? So the very first part is to be there, in which student just we have to check the function is given as n to n, natural number to natural number, and fx equals to x square is 1 1 or not. So it is 1 1, but it is not said to be the onto. No. Next, second part of this question number 1 we have to take here. So the second part of question number 2 we are taking here. The change is only this is to be defined as z to z. This is to be defined as z to z. Z to z means set of integers, and I think each and every student know very well about the set of integers, because integers can be either positive or negative, no problem. And the fx is to be written as x square. The function fx is to be written as f of x equals to x square. So basically student, just we have to check the 1 1 case. Just we have to check the 1 1 case. Then let f of x, you can say that let x1 comma x2, let x1 comma x2 belongs to the integer, set of integers, and this integer will be the domain. Is it to be clear? Here both the domain and codomain are same, but always student we have to take the particular element from the domain for 1 1 case. So basically this particular z will belong to the domain part, and in such a way that you can say that such that f of x1 equals to, it is said to be the f of x2. Now you can say that this one should be written as x1 square, this should be written as x2 square. Now student, x1 square equals to x2 square. Now the problem is either x1 equals to x2 or either x1 equals to plus or minus x2. It will depend on the case of x1 x2, because x1 x2 belongs to the set of integers, and integers can be either positive or negative. So basically here student you will get the result as x1 equals to plus or minus x2. So if we will obtain x1 equals to plus minus x2, then so it is not 1 1. So it is not 1 1. And you can check one more case. Suppose we have to make the mapping here. Then suppose we have to take this is integer, and here we can say that this is minus 2. Then the image of this will be 4, and here plus 2 you can take, then the image will be 4. So basically these are the two elements. These are the two elements here, and these two elements has the same image. These two elements has the same image. Then this case is said to be the many-one case. Is it to be clear? So you can check like this also. You can map this particular mapping, and according to that you can take the element. Then you can automatically say that this function is not said to be the case of 1 1. So it is not 1 1. Then you can say that this is said to be the many-one function. Is it to be clear? Now the second case we are taking here onto. Second case we are taking here onto. So whether the given function is onto or not, just we have to check this part. So for onto student, always we have to take let f of x equals to y, and here x square equals to y. Then x will be written here plus or minus a square root of y, because here just this x belongs to the set of integer. So integer can be either positive or negative. That's why we are saying that x equals to plus or minus root y. So basically student, this thing is to be get converted, but for onto just we have to check for each and every codomain element there should be the pre-image in domain will lie or not. So basically suppose x equals to, suppose for all y belongs to the set of integer, whether we are checking this will particular part will lie in the set of integer, because the domain is always said to be given as the set of integer. So suppose we have to take an example. Suppose we have to take y equals to minus 2, then square root of minus 2. Square root of minus 2 does not belongs to the set of integer, because square root of minus 2 will be taken as the complex number. You can say that the imaginary number. Is it to be clear? So you can say that square root of minus 2 does not belongs to the set of integer. So for all y belongs to integer, x does not belongs to integer. You can check this example, and definitely student, in examination just we have to provide the example so that the concept will be get clear to each and everyone, and definitely you will get the complete marks. So here for all x y belongs to the z, x does not belongs to the z, so it is not on 2. So it is not on 2. Is it to be clear? Suppose any of the function is not set to be the on 2, then what? Then we can say that the function is set to be in 2 automatically. Suppose any of the function is not set to be on 2, then automatically it will become the into function. Is it to be clear? So in the second part of the question number 2, always student, according to this domain and codomain, the answer will be get changes, because the definition will not change here. Fx equal to x square will be same in the previous question as well as in this question, but here the change in the domain and codomain. And so student, this is the very important part. We have to know about the domain and codomain of each and every function. Is it to be clear? Now we will take the third part of the question number 3. In the third part, only the changes is domain and codomain, means where the codomain and domain both are set to be the real number, set of real number. So pause the video to note it down. After that we will start the third part of the question number 3, and in the question number 2, third part is to be given as any function f is to be given from real number to real number, and you can say that this fx is again set to be the x square. Is it to be clear? No problem. Again student, we will do work for the real numbers, and I think each and every student know very well about the set of real numbers here. So basically here for 1 1, again for 1 1, what we will say? We can say that let x1 comma x2 both belongs to the set of real number, such that f of x1 equals to f of x2. Now student, f of x1 will be written as x1 square, and this is written as x2 square. Now as per the rule, whether we are obtaining x1 equals to plus minus x2 or x1 equals to x2, it will depend on the set of real numbers. Now student, you know very well the real number can be either positive or negative, means you can say that here on behalf of real number we can say that this x1 should be equals to plus or minus x2, because here you can say that x1 and x2 both should belong to the set of real numbers. That's why we are saying that plus or minus x2, and so it is not 1 1. So it is not 1 1, because student, for the 1 1 function always we will obtain the condition as x1 equals to x2 exactly. Neither of other definition we will get required. If any other type of expression we will get, means the relationship between x1 x2 is other than x1 equals to x2, then it is said to be the many-one function. Is it to be clear? So in this case this is not said to be the 1 1. Second case, we have to check for the onto. So basically in the onto case we have to say that let f of x equals to y. So basically let fx equals to y, then x square equals to y. Now you can say that again we are saying that plus or minus square root of y. Now student, for all y belongs to the real number, because here the codomain part is said to be the set of real number. So basically if the real number is to be given as the codomain part, then we have to check the pre-image for all the real numbers. So basically we are taking, suppose we are taking y equals to suppose minus of 3, and that should belongs to the real number, but you can say that square root of minus 3 does not belongs to the set of real number, because it should be an imaginary number. So basically student, y equals to minus 3, that should belongs to the real number, means we are taking any of the element from the codomain, and just we want to check the pre-image whether it will be existed or not. So basically here we will get the value of x as minus root 3, square root of minus root 3, but square root of minus 3 is not to be available in the set of real number. That's why we can say that, so for all x belongs to real number, x does not belongs to the set of real number, so it is not on 2. Is it to be clear? So student, according to the definition, easily you can provide the answer of each and every part, but we have to keep in mind the concept. Is it to be clear? Because in each and every case of the solution part, here you can check the one important thing, just we have to know about the proper definition and proper logic of the 1 and on2 function. After that definitely you will get the answer of the each and every question. Is it to be clear? So pause the video to note it down. Then after we will take the fourth part of the question number 2, where again student the function will be changes. Fx equals to x cube is to be given, and again we have to take the natural number to natural number and integer to integer. There are two cases we have to take. So the next question number 2 part 4 we are taking here. So in this part any function f is to be given from natural number to natural number, and here the fx will be taken as x cube now. So student, here in the previous questions the odd even power is to be taken of x, but here the odd power is to be taken here. So according to that we have to process this thing. So basically for 1 case, just we have to say that let x1 comma x2 belongs to the set of natural number such that f of x1 equals to f of x2, and here we can say that x1 whole cube equals to x2 whole cube. Is it to be clear? Now student, any cube is to be there, then definitely there should be no problem related to the plus or minus, because plus or minus sign will be occur when the any even power will be there. Here the power will be odd. Is it to be clear? So there should be no problem. If any negative number is to be get cube, then definitely its cube will be a negative number, and cube of any positive number will be positive. So if either of the natural number will be there, then you can say that both the numbers are to be said to be positive here, then their cube will be positive. So we will get the answer x1 equals to x2 only, because here x1 and x2 belongs to the natural number. Is it to be clear? So definitely student, when we are taking the cube root, then definitely we will obtain the condition as x1 equals to x2 here. Now you can say that so it is 1 so it is the case of 1 and suppose if it is 1 then what can you say about the many one? It cannot be a many one function. Is it to be clear? The next part is said to be the on2. So basically for the on2 what we are saying, let f of x equals to y, then f of x will be become x cube will be taken as y, then what is x will be written as y raised to power 1 by 3. Now student, what should be the codomain of the given function? So codomain of the given function is said to be the natural number. So you can say that for all y belongs to the natural number, definitely the cube root of any natural number should be natural number or not. We have to see this thing. Is it to be clear? Means for the on2 function we just have to check whether the codomain element has the pre-image in domain or not. Is it to be clear? So basically what we are saying here, suppose we are taking 2 belongs to the natural number, then if y equals to 2, then x equals to 2 raised to power 1 by 3, and which does not belongs to the natural number. You can just provide an example student in which the particular condition does not satisfy. Is it to be clear? Suppose in any of the case it should be satisfied, then definitely you can say that there should be no requirement to take any example, but in that case you know very well this 2 raised to power 1 by 3 is not to be available in the set of natural number. So you can say that for all y belongs to the natural number, x does not belongs to the natural number, so it is not on2. So it is not the case of on2 function. Suppose it is not said to be the on2, then it is said to be the into function. Is it to be clear? So in this question student, only the basic thing that should be changed here. Here it is to be taken as the cubic part of the x. Is it to be clear? So there should be no problem in the calculation part. The very simple type of questions are to be there. Easily you can handle each and every part, and each and every part will be treated in the same way. Is it to be clear? So pause the video to note down the answer. Then after we will move to the next and last part of the question number 2, that is fifth part. Fifth part is to be just fx is to be given as x cube, but here in this fifth part the domain and codomain is said to be the integer to integer. So next part we have to take here. So basically student, the question number 2 part fifth we are taking. So in this fifth part f is to be given from z to z, and here again f of x equals to given as x cube. Is it to be clear? And again we are doing the same job, because just we want to check whether the given function is injective or surjective or not. So basically we have to check the injectivity, or you can say that we have to just check the 1 1 condition. So you can take, let x1 comma x2 belongs to the set of integer such that f of x1 equals to f of x2. Is it to be clear? So basically here you can say that x1 whole cube equals to x2 whole cube. Is it to be clear? Now student, x1 whole cube equals to x2 whole cube, and you know very well about this thing. Any negative number cube will be negative, and any positive cube, number cube will be positive here. Is it to be clear? Means in the case of odd power, if any negative number is to be there, then its cube will be negative. Any positive number is to be there, then its cube will be positive. Means there should be no problem related to the plus or minus here. So definitely according to the given situation, again we will get the x1 equals to x2, and here we have to write x1 x2 belongs to the set of integer. Is it to be clear? And in this case, so it is said to be 1 1 case. So it is said to be the 1 1 case. Is it to be clear? You can draw the mapping also. Suppose any of the integer minus 1 is to be there, then minus 1 cube is minus 1. Suppose minus 2 is to be there, then its cube will be minus 8. Suppose 2 is to be there, then its cube will be 8. Means we are getting the different type of distinct images in the codomain. That's why this function is said to be the 1 1 case. Is it to be clear? Now the second case, just we have to check for the onto. This is the very important case. So let f of x equals to y, then x cube equals to y, and x will become the y raised to power 1 by 3. Now student, we have to just convert the x in terms of y, and after that just we have to find the pre-image, whether the pre-image of any element is to be possible or not. So basically student, we have to check the pre-image of codomain, and here for all y belongs to the codomain is set of integers. So we can take any of the integer in case of y. So let we will take, let y equals to minus 2 suppose, then x will become minus 2 raised to power 1 by 3, and student, no perfect cube is to be there, so this does not belongs to the set of integer. So you can check this example. Suppose we are taking any minus 2, and minus 2 definitely will belongs to the integer, no problem. Then what should be the answer of x according to this part? So the value of y will be minus 2 is to be put here, then x will become minus 2 whole raised to power 1 by 3. Then this particular part does not have the perfect cube root, then definitely this part does not belong to the set of integers, and integers cannot be written in the fractional part. That's why you can say that for all y belongs to z, x does not belong to the z, so it is not onto. So it is not said to be the onto, because if any one element does not has the pre-image in the domain, then it is not said to be the onto case, it is said to be the into case. Is it to be clear? So question number 2 is the very important part student, to understand the basic concept of the 1 1 and onto. Each and every case just we have to discuss here. So you have to keep in mind each and every case, and according to that you will just get the processing of 1 1 and onto. But how to write in examination copy, this is the very important task for you. So how the written process is to be taken. So student, we have to write these things always. Is it to be clear? So make a proper process of checking of 1 1 and onto. There are so many definitions we have to also discuss for the 1 1, but student, we are just using the regular process that should be applicable for each and every cases. So this is the general way by which we are just proving that either the function is 1 1 or not, onto or not, many one or not, into or not. Is it to be clear? So this is your question number 2. So pause the video to note it down. After that student, just we will take the next question number 3 of exercise 1.2. So look at the question number 3. So you can say that the very important question number 3 is to be given. Prove that the greatest integer function f, and f will be taken from R to R given by fx equals to greatest integer of x is neither 1 1 nor onto. Is it to be clear? So basically student, a very basic question is to be there. So we will just solve the question number 3 here. So in this question number 3, any function f that should be provided from real number to real number, and this function fx is to be written here greatest integer of x. First of all, student, you know very well about the greatest integer function, because greatest integer function will always provide an integer which is just less than the given value, which is just less than the given value. Is it to be clear? So basically, student, on the behalf of mapping, suppose any of mapping is to be drawn like this, then what we can say that suppose this is the set of real number, this is the set of real number. Suppose we are taking 1.1, then the greatest integer of 1.1 will be 1. Suppose the greatest integer of 1.2 is to be taken, then it is again obtained as 1. Suppose greatest integer of 1.3 is to be taken, then again it is said to be the 1. Means you can say that there are so many elements in domain whose image will be same in the codomain. So basically this particular function is said to be many one. This particular function is said to be many one. So on behalf of mapping, just you can check this part. Is it to be clear? Student, I will just tell the graph of this greatest integer also, because this graph is to be very important for calculus part also, where again we have to see the basic concept of greatest integer function in the calculus part. So we will also draw the graph of this particular function here. Is it to be clear? So in this case, just we are saying that this on behalf of mapping, if we have to draw, then it is not said to be the 1 1. So how we will write this thing? So 1 1, for 1 1, let x1 comma x2 belongs to the real number, they such that f of x1 equals to f of x2. Is it to be clear? So basically, student, if we are saying that the f of x1 equals to f of x2, means this is said to be the many one, and in this case of mapping, just you can check whether the given function is many one or not. So basically here we have to write greatest integer of x1 equals to greatest integer of x2. Here this close bracket will represent the greatest integer function here, and student, greatest integer function will always provide a value which is the integer, and which is the integer given to the least value. Is it to be clear? So any greatest integer will be same, this is to be given here, then you can just say that here x1 not said to be equals to x2. How you can say this part? So for this part, you can just let x1 equals to 1.3 and x2 equals to 1.4, then both the greatest integer of x1 equals to x2 or not. So easily you can say that greatest integer of x1 means 1.3 will be 1, and greatest integer of 1.4 will be also 1, means both the part are to be same. But here you can check the x1 and x2 whether they are same or not. So definitely, student, x1 is not said to be the x2 always. Is it to be clear? And suppose any of the one case is to be get wrong here, then it is not said to be the case of 1 1. So here just we have to specify this example. So it is not 1 1. So it is not 1 1. Is it to be clear? And it is not 1 1 means you can say that this is the case of many one. Next we have to check for the onto. So for the onto, student, f of x equals to y. Let f of x equals to y. Now f of x is greatest integer of x, and that should be equals to y. We have to write. Now this particular symbol will not be erased here. Always we have to keep in mind this greatest integer will provide an integer value here. Now we have to check for all y belongs to the real number. For all y belongs to the real number. Suppose we have to take any real number y equals to 1.3, that belongs to the integer. So student, greatest integer of x equals to 1.3, which is not true, which is not true, because no any greatest integer is found to be the fractional number, because always any of the greatest integer function will provide the answer, then answer should be taken as positive always. So definitely, student, here this greatest integer of x will be obtained as 1.3, which is not said to be which is not said to be true, means the pre-image of this particular element is not found in the domain part of the given function. So x belongs to R, then x does not belongs to R. Is it to be clear? So it is not onto. So it is not onto. So basically student, you can see this example. This is the very important example. You can just see here. Is it to be clear? So in this way, you can just say that this given function greatest integer is neither said to be the 1 1 and nor said to be the onto. Now the one more important part, the graph of this function. And I think student in the class 11th, just you have to draw the graph of greatest integer function also in the case of real number. So you can just make the graph. So here from 0 to 0.1, from 0 to 0.1, so we have to make an open circle here. We have to make an open circle. So no problem. Next we have to draw the open circle like this. Suppose this is 1. So the graph will be like this. Here just we have to dark this line, because the answer of 0 to 0.1 will be 0, and here next this one is to be get included here, and we have to make the graph like this. We have to make the graph like this. Is it to be clear? And student, the graph should be clear to each and every student here, because this is 1, this is 2, this is 3 and so on. Here this is 1, this is 2, like this. And similarly you can plot the graph like this. You can plot the graph like this. Is it to be clear? Here this is -1, this is -2, this is -1 and this is -2. Is it to be clear? So this is the step up function, you can say that. This is the case of step up function. This is also called as the step up function. Is it to be clear? So basically student, this is the basic graph of this greatest integer function, because here from 1 to 2 it will provide the answer 1. From 2 to 3 it will provide the answer 2, and 3 to 4 it will provide the answer 3, like this. Is it to be clear? So mainly the graph of greatest integer we have to keep in mind always. And now what is the graphical manner to check the 1 1? So basically we can say that if we are taking we are drawing any line parallel to x-axis, and if it will intersect at more than one point, then it is not said to be the 1 1. So definitely student, suppose we are drawing any line, suppose we are drawing any line like this, then definitely it will be intersected at more points of this graph, then it is not said to be the onto in 1 1 function. Is it to be clear? So this is the graphical definition of 1 1, you can say here. So according to the graphical definition, this particular function is not said to be the 1 1 case. Is it to be clear? And what can you say about the onto? Means for each and every codomain value, its pre-image will be existed. Suppose we are taking any value here. Suppose here we are taking minus of 0.4. Then no particular graph in the left or right side we will obtain, means no particular value of x or no particular pre-image of this particular given value will be existed for the given graph. That's why it is not said to be the onto function. So basically student, just I want to tell the graphical part also, because the graph is the very important case where we have to see the various type of logics according to the given function. Is it to be clear? So this is the answer of the question number 3, where any of the greatest integer function is to be given, then we can say that the greatest integer function cannot be 1 1 and never be onto, means neither of 1 1 never be onto. Is it to be clear? So pause the video to note it down. After that we will take the next question number 4 of NCERT exercise 1.2. Is it to be clear? So next question we have to see here. So the next question we will take here, the question number 4. You can see the question number 4 here. So basically student, the question number 4 says that, so that modulus function f r to r given by fx equal to modulus of x is, again we have to check what, whether it is 1 1 or not, onto or not, and what can be the other scenario of this particular function. So basically we have to just again take the question and we will solve this question here. So the question number 4 is again a very familiar question, I think student, because each and every student know very well about the modulus function. What should be the basic functioning of modulus function? Modulus function will always provide the positive answer, means any of the input is to be given to the modulus function, then output part will be always said to be the positive, never be a negative part is to be obtained. Is it to be clear? So basically here f r to r is to be given and fx is to be given as modulus of x. So definitely student, we will check for the 1 1 case first of all, and I think each and every student know very well about the graph, and you can just see the answer on behalf of mapping also here. So just you can check these parts sometime. So suppose -2 is to be there, then answer is to be obtained as 2. Suppose 2 is to be there, then again answer is to be obtained as 2. This is the set of real number, this is the set of real number. So any function is to be defined from the real number to real number, and modulus is what? So definitely student, modulus will provide the always a positive answer. So definitely minus 2 modulus is 2 and 2 modulus is again obtained as 2. So it is said to be the many-one function. Directly on behalf of this mapping, you can just check the answer. But how to write properly here? So basically student, we can say that let x1 comma x2, let x1 comma x2 belongs to the set of real number such that f of x1 equals to f of x2. So basically here modulus of x1 equals to modulus of x2. So definitely student, here any modulus is to be given as the another modulus equality sign is to be given, then definitely we cannot say x1 equals to x2. Sometime it may be happen, suppose both the numbers are positive, then it will be happen. So here we can say that if x1 and x2 both are positive, then x1 equals to x2. But suppose we have to take x1 equals to minus 2 and x2 equal to 2, then minus 2 modulus is always 2 and plus 2 modulus is always found to be 2. Means in that case, whenever x1 is negative and x2 is positive, again both the modulus are found to be same, but that x1 and x2 are not found to be same. So definitely student, if each and every case we have to check, in each and every case if we will get the result x1 equals to x2, then it is said to be the 1 1. Suppose in any of the case it is found to be x1 not equals to x2, then it is not said to be the 1 1 function and it is said to be the many-one function. So basically here you can just provide an example. Let x1 equals to minus 2 and x2 equals to 2, and here you can say that x1 equals to not equals to x2, but you can say that modulus of x1 equals to obtained as modulus of x2. Is that to be clear? So in according to this example, sometime it is to be obtained as x1 equals to x2 and sometime it is obtained as x1 not equals to x2. And you can just see this example. Here x1 and x2 both are the different, but their modulus will be found to be same. So definitely student, here you can see that x1 is not found to be same as the x2. So it is not 1 1. So it is not 1 1. Is that to be clear? So this is not said to be the injective function. Now the second thing we will check for the onto part. So for the onto, let f of x equals to y. For the onto we have to take let f of x equals to y, and f of x is what? Modulus of x equals to y. Is that to be clear? So definitely student, here we have to check for the codomain value for all y belongs to the real number. Suppose we are taking any of the real number and for example we have to take y equals to minus 3, that should be belongs to the any real number, but you can say that minus 3 equals to modulus of x, which is not true, which is false, because any modulus will always provide the positive answer. No, any modulus will provide the negative answer. That's why student, neither of this modulus will take the negative value. So here for all y belongs to the x real number, x does not belongs to the real number, so it is not onto. So it is not onto function. Is it to be clear? So each and every case student, just you have to mention here and just you have to declare whether the given function is said to be the 1 1 or not, 1 1 many one or not. Is it to be clear? Onto or not, into or not. So this is the regular process, and in these type of process sometime you have to just think about these type of examples. Definitely student, you have to mention the example whenever you are writing any of the answer, so that the things are to be get clarified to each and everyone, and that's why you will get the proper marks in the examination also. One more important part related to this question student, just we have to draw the graph. Just we have to draw the graph of this function. So if I think each and every student know very well about the graph of modulus x. So if we have to draw the graph, then first of all we have to see the basic definition. This is minus x if x is less than 0, and this is x if x is greater than or equals to 0. And the graph of modulus function will be like this V-shaped graph is to be there, and this is x-axis and this is y-axis. Is it to be clear? Because this function is to be defined from real number to real number. So definitely you know very well about the graph, and this particular graph will be very important in the entire calculus part also. We have to see this thing where also. So basically, if any of the line is parallel to x axis is to be drawn, then it will be intersected at 2 points. And definitely, if any line parallel to x axis intersect the graph at more than 1 point, then it is always said to be the many one. Is it to be clear? Next for onto, we have to check the codomain. So the codomain of this function is said to be the set of real number. So for the real number, for these positive real numbers, definitely you will get the pre-image because the graph will be available. But here, suppose we are taking any real number here, then in the left and right hand side, you will not obtain any of the graph. And if any of the graph is not to be obtained here, then definitely student, you can say that this particular element does not has the pre-image in the domain, and this is not said to be the case of onto, means this is the case of into function. So basically student, we have to keep in mind the graphical manner also, because sometimes the graph is the very important, and these graphs are to be also useful when we have to read the basic calculus part. Then definitely these graphs are the very important sections for us. So basically student, in this question we are saying that modulus function from real number to real number is neither said to be 1 nor said to be onto. Is that to be clear? So student, in this video up to question number 4 we have to discuss from your NCERT exercise 1.2, and that should be related only the 1 case and onto case, and the some remaining questions are to be also there, which are to be discussed in the next video. Till that student, again you have to do the practice of writing manner, means how to write the particular case of 1 as well as the onto. Is it to be clear? Then the remaining question will be solved in the next class, and you can just try the remaining questions by yourself only, and if any of the doubt will be there, then you will clear that doubt by seeing the next video student. So pause the video to note down these things, and we will meet in the next video of the some remaining question of exercise 1.2. Thank you.